Here we are. We're going to talk about 2.3a, comparing linear functions. Let's go to work. Sure, I got my highlighter. We're ready to go. In this section, we'll still be using the slope-intercept form of linear equations. For fun, what is slope-intercept form for linear equations? Y equals mx plus b. All right, to be able to accurately compare functions, we need to get the function in the same representations, solve various representations for functions, find the rate of change in each representation, and find the initial value in each representation. So that's what we're going to be doing over and over again, is finding the rate of change, finding the initial value, no matter which way it's given to us. Defining variables and writing equations. We want to make sure we can correctly identify the initial value in each situation so that we define our variables correctly. The key to equations is finding the lowest terms, proportion, ratio, or slope. How many people have a problem with that phrase right there? I don't know what that means. I better ask Coach when we go back to class. I'm not exactly sure what that means. Example 1, a company gained value at the rate of $200,000 per day after its IPO, initial public offering of $1 million. What is actually being compared here? Hint. The hint is the word rate, which compares the value in dollars and the number of days a company opening to the public stock market. That means we could define the variables and equations as follows. V is the value of the company. D is the number of days since the IPO, or initial public offering. And the equation then would be V equals 200,000 D plus 1 million. Notice that 1 million is the initial value and 200,000 is the rate. Again, looking up here, 200,000 per day and an IPO of $1 million. Note that in this case, the company was initially worth $1 million. That's why the 1 million is the initial value in this equation. Let's look at example 2. To be a member at a gym, you must pay a one-time $25 entry fee plus $10 per month. How many feel like they can find the rate of change in the initial value there easily? Again, think of the slope or rate of change in this problem. How does the rate change? It changes by $10 per month. The entry fee does not change. That's not part of the change. What changes is how much you pay when compared to the number of months you signed up for at the gym. That means we are comparing your amount that you pay and the number of months. We define the variables and write the equation based on that as follows. C will be the cost of the gym membership. M will be the number of months for memberships. Therefore, our equation will be C equals 10M plus 25. $25 fee is the initial value because it's what you pay initially. The cost does not change over the number of months. because it's the initial value. How we doing? So far, so good? Solving equations. Let's solve some linear function problems that have initial values using equations. Consider the gym membership situation from above. We could ask how much it would cost to be a member for 1 year. That would mean that M equals 12, since there's 12 months in a year. We'll substitute and solve as follows. Here's our original equation. We'll plug 12 in. 10 times 12 is 120. 120 plus 25 is 145. This means that the cost for 1 year would be $145 total. We could also solve this problem if we know the cost and not the number of months. For example, how many months of membership could you buy if you had $365? That would mean C equals 365. So we'll substitute and solve as follows. Notice they put the 365 in for C. Then we subtract 25 from both sides. It cancels on the right, and then 365 minus 25 is 340. Divide by 10, so M equals 34. So we could buy 34 months of membership with $365. Larth. H stands for? How many of you read through this just like this? Do you understand what I'm saying? Is this helpful? Yeah, you all shake your heads yes. I want you to do this on your own without me holding your hand and walking you through it. Okay? I want you to stop being freshmen, start being responsible for yourself. Education is not what I do for you. Education is about making yourself unstoppable. Did you hear that? That was good right there. Come on. Woo! Making yourself unstoppable. Nobody can hold you back but you. Just like nobody can make you great except you. Can I get an amen? Amen. But if you want to be great, you have to be willing to do the little things that allow you to acquire the skills that you need. The little things aren't easy. Moving on. Finding the initial value, y-intercept, or the rate of change. Pretend that a company gained value by $100 per day, and after 7 days was worth $850. What was the initial value of the company? Well, I don't know, but I'll bet we could figure it out. Let's start by defining the variables and writing the equation as best we can. We know we're comparing the value of a company in a number of days. So we might do this. V is the value of a company in dollars. D is the days since the IPO, right? So the only thing we really know at this time is our rate of change. So we plug that in front of the independent variable. Notice that we don't know the initial value because that's what the question asked us to find. Therefore, we'll just leave the variable B in the equation as a placeholder for our initial value. However, we do know that after 7 days, or when D equals 7, the company is worth $850, or V is $850. So let's substitute those values in and solve for our initial value. Notice D is 7 and V is 850. 7 times 100 is 700. Subtract 700 from both sides, and you end up with B equals 150. Therefore, the initial value of the company was $750. Look how easily now we could substitute that 750 in for that B to have our linear equation. What'd I say? Excuse me, 150. I apologize. My brain, my mouth aren't always connected. Sometimes there's a disconnect. Ever happened to you? Yeah, it happens to me. Similarly, we could solve for the slope or rate of change in a problem. Consider an appliance salesman who gets paid $50 every day, plus some unknown amount of money for every appliance that they sell that day. Let's say the appliance salesman made $475 after selling 17 appliances. How much did he get paid per appliance? Again, we'll define our variables and write the first equation. P is the total pay. A is the number of appliances sold. Getting this, Mr. Garbrandt? So P equals MA plus 50. We don't know our M or our rate of change or our slope yet. Notice that $50 every day is the initial value. It never changes. We also left M in the equation because we don't know the rate he gets per appliance. Let's substitute what we know, which is that A is 17 and P is 475. Then solve for M. So we put the 475 in, we put the 17 in. So subtract 50 from both sides, divide by 17, and M equals 25. This means that the salesman gets paid $25 per appliance that he sells. Isn't it amazing how we can find that if we have enough information? Comparing linear functions using equations. Now we have two variables to compare in equations, the rate of change and the initial value. Let's say that a restaurant wants to buy paper plates in bulk. So they want to join a warehouse store, like a Sam's Club. There are 3 stores they could join. Store 1 charges a membership fee of $100 and $25 per bulk package of paper plates. Store 2 charges $50 and charges $30 per bulk package of paper plates. And store 3 charges a membership of $200 and then $20 per bulk package of paper plates. Let's start by defining the variables for each store. C is the total cost. P is the number of bulk packages. So here are our equations. Notice the initial value, rate of change, initial value, rate of change, initial value, rate of change. Becomes very easy then to make the equations, doesn't it? Hey, lose the glassiness in your eyes and stay focused. We're almost done. Store 1, C equals 25P plus 100. Store 2, C equals 30P plus 50. And store 3, C equals 20P plus 200. Which one has the highest rate of change? Raise your hand. Which one has the highest rate of change? 30P, store 2. Which one has the largest initial value? Store 3. It's pretty easy to compare once they're in the same form, isn't it? Now, it would be difficult to ask which store is the cheapest because it depends on how many packages of paper plates you buy. However, we can ask which store has the cheapest rate of packages per paper plate. Which one does? Yeah, store 3, $20 per package. Which store has the highest membership fee? Yep, that would be store 3 as well, since it charges $200. Which store would give the overall cheapest price if the restaurant needed to buy 2 packages of paper plates? What if it were 5 packages? What if it were 10 packages? We'll substitute each of those values in for P and solve for C. And when you do that, we could see which one's the cheapest? Store 2. What if it was 5 packages? Notice I'm plugging in the 5. Plugging in the 5. Who wins if it's 5 packages? Still store 2. So if you're not going to buy very many packages, store 2. How about 20 packages? All of a sudden now, 1 and 3 are tied. So now you can compare them and you can say, hey, if you've got, a small number, we're going to go to store 2. If we got a middle number, we go to this store. And if we want a lot of packages, then we would go to store 3. In this case, there's a tie for the cheapest store between store 1 and 3. You should be able to extrapolate or think ahead and see if the restaurant needs to buy more than 20 packages of paper plates in bulk. Store 3 will always be cheaper. Can you explain why? Why would store 3 be the cheapest?
It's got the lowest rate.
Absolutely, because it's got the lowest rate of change. All right, I want you to do 2.3a, even questions, 2 through 22, or 24, 2 through 24, the whole 12 problems. Good luck. Have a great day.